over there.
Why? Jerk.
Okay. So we're going to try to explain the logic behind the unit circle very quick. And we're going to do it in about 12 minutes. So please try to focus and pay attention here for about 12 minutes. We're going to start with a little geometry review. You got an isosceles right triangle. Isosceles mean two sides are equal. These two angles are 45 degrees, that's 90. We're going to make the hypotenuse 1 unit long. We're going to call these two sides A. They're the same, so we can use the same variable. So we have a squared plus a squared equals 1 squared. Pythagorean theorem. So that gives us 2a squared equals 1. We combine here and square the 1. Divide by 2. That gives you a squared equals a half. Let's bring this up a little higher where you can see it a little better. Square root both sides. So I'm going to square root the a squared. I'm going to square root the 1. I'm going to square root the 2. So a comes out, square root of a squared is a. Square root of 1 is 1. A equals 1 over the square root of 2. So I'm just using Pythagorean theorem solving for a. Any questions so far? Okay. Next, normally with trig, we don't leave square roots in the denominators. That square root of 2 is called an irrational number. We don't leave irrational numbers in the denominator. What we want to do is multiply the top and bottom of this equation by the square root of 2. That's called rationalizing the denominator. You might remember doing that in either geometry or trig class, pre-calc 1. So what that's going to do is give us this. A equals square root of 2 on the top. 1 times square root of 2 is square root of 2. On the bottom, square root of 2 times square root of 2, what does that equal? 2. Square root of 4, which is 2. So basically what we just figured out is that when you have a radius of 1, and you have an isosceles right triangle, the other two sides are both going to be square root 2 over 2. That's what we just determined. Where does that fit in the unit circle? Well, in the unit circle is a circle with a radius of 1 unit, and it's got the x-axis going down the middle and the y-axis going down vertically down the middle. So if we draw a triangle right here, and this is 45 degrees, and this is 90, that would mean this would have to be 45 also, because the three angles of the triangle have to add up to 180. And remember, this is on a coordinate plane. This is the x-axis and the y-axis. So what would be the coordinates? What would be the x and y coordinate of that point? The x coordinate would be square root 2 over 2, and the y coordinate would be square root 2 over 2. How about if we went into quadrant 2 over here? Now, we're going to go the same distances, now we're going to go left and up. How's that going to change the coordinates?
X will be negative.
X will be negative. So you'll have negative square root 2 over 2, positive square root 2 over 2. And it all comes from this geometry that I was doing over here. If you come down here into quadrant 3, you're going to go left and then down, so both coordinates are going to be what? Negative, yeah. So this is negative square root 2 over 2, negative square root 2 over 2. If you're taking a quiz over this, you'll have to be able to do this next week. Quadrant 4, right there. We're going right and then down, so the x coordinate would be positive square root 2 over 2, the y coordinate would be negative square root 2 over 2. Our degree measurements, let's put those in pink here. We're thinking about rotating around the circle. 0 degrees is right here. That's considered 0 degrees. So at this point right here would be 45 degrees. Straight up. Again, this is our initial side length. Side is on the x-axis. So we rotate straight up. That's 90 degrees. Go another 45. That'd be 135 degrees right here. Another 45. This is 180 right here. Another 45. It's 180 plus 45. 225, right? Another 45 is 270. Another 270 plus 45, 315, right? Another 45, we're back here to 360 degrees. So we have 360 degrees around a circle. Now, while we're on that, let's talk a little bit of trig. I know you've had some basic right triangle trig before. And you've had some stuff, you've probably learned same old horse came hopping through our alley or SOHCAHTOA. Has anyone ever heard that? Same old horse came hopping through our alley or SOHCAHTOA? Okay, SOHCAHTOA. All right. So remember, so this side right here is 1, for example. This side right here is square root 2 over 2. This side right here is square root 2 over 2. This is my angle that we're dealing with right here. So if I was going to take, for example, the sine at 45 degrees, I would take the opposite side divided by the hypotenuse. So here's 45 degrees. The opposite side would be right here. I take square root 2 over 2 divided by 1. And that would give me what? Square root 2 over 2. So the sine, you're taking the y-coordinate divided by 1, which just gives you the y-coordinate. So that's why this y-coordinate actually represents the sine of 45 degrees. And if you do cosine, cosine is adjacent over hypotenuse. So the adjacent side would be this bottom side. So you take your x-coordinate divided by 1, which would just give you your x-coordinate again, right? When you divide by 1, it doesn't really change it. So square root 2 over 2 divided by 1, square root 2 over 2 again. So that's your cosine. So your x-coordinate is always going to end up being your cosine of your angle. Your y-coordinate is always going to end up being your sine of your angle. The reason is because when you put it over 1, you get just that x or y coordinate again. Any questions about that? About 6 more minutes. Okay. Let's quickly write in, what would be the coordinates of this point right here if we know the radius is 1? What are the coordinates right there? 1, 0. Yep. How about this point at 90 degrees? What would be the coordinates there? 0, 1, right? 0 to the right, up 1. How about this point? Negative 1, 0. Good. Down here would be 0, negative 1. And again, the x-coordinate is your cosine of your angle. Y is your sine. All right. Let's move on to the 30, 60, 90 triangle I have drawn right here. Let's get rid of this other work. 30, 60, 90 triangle. The two side lengths aren't going to be the same. You might have learned some rule, the relationship between them in geometry. We're going to discuss that now. Again, we're going to use Pythagorean theorem. X squared plus y squared equals 1 squared. Now, let me show you another picture. This is how I like to picture 30, 60, 90 triangles. That's 30, that's 60. I like to imagine another triangle right here. A matching triangle underneath it, but that's 30 and that's 60. So this would be 1, this would be 1. So really we've got 60, 60, 60. What type of triangle is that? Equilateral. Equilateral. So that's 1 and that's 1. What's this total going to be? This total's got to be 1 here also. Because it's equilateral. It's got the big, look at the big triangle. 60, 60, 60. Those all have to be 1. So what would this length have to be right here? A half. So the y actually has to equal a half right here. Y coordinate's going to be a half. Let's change this y to a half. And by just imagining another, this triangle flipped down, you can kind of come up with that reasoning. Next, let's square a half. A half of a half. What's half times a half? A fourth, yeah. So x squared equals 1/4, or plus 1/4 equals 1. Subtract a fourth off both sides, you get x squared equals 3/4. Square root everything. The square root of x squared is x. The square root of 3 is square root of 3. The square root of 4 is 2. So this x coordinate ends up being square root of 3 over 2. So, how does that help us? Well, let me erase some of these triangles so we don't have such a mess up here. If I'm trying to go at a 30 degree angle here, and I draw down, this is 90, what would this angle have to be right here? there's my 30, 60, 90 triangle. Here's what I want you to notice. The longest side on a 30, 60, 90 triangle, when the radius is 1, which it always will be on the unit circle, the longest side is always going to be square root 3 over 2. The shorter side is always going to be a half. So I'm going to go over square root 3 over 2, up a half, so my coordinates at 30 degrees are going to be, this is 30 degrees right here. If we go by this angle, this interior angle in the middle here, is square root 3 over 2, and then up a half. Same thing come in this direction. This would be 180 minus 30, this would be 150 degrees. That would also be square root 3 over 2, a half, except what's going to be different? The negative x coordinate because you're coming left. You're still going up, but negative x coordinate because you're going left. So it's negative square root 3 over 2. Same thing right here. You're coming left and you're coming down. And if you do 180 plus 30, that's 210 degrees right in there. And left and down, so they're both going to be negative. So it's going to be negative square root 3 over 2, negative a half. Questions so far? All right, let's go right here. That's 360, back up 30, so that's 330. What would be the signs on this one? Positive or negative, negative, positive, 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 what's it going to be? Positive, negative, you write down. And the longer distance is your square root 3 over 2, so that's your x coordinate. And then down a half, because you're going down the short distance down right there. One more color here. All right, we've got a few points left. This point here. Let's say this is 60 degrees now. Which would make this 30. So it's still the same triangle, but turned a different direction. The orientation's been switched a little bit. Now the short dimension runs sideways. The longer dimension runs up and down. So now what do you think the coordinates of 60 degrees are going to be right here?
1/2, 3, square root 3 over 2.
Right. Now the shorter distance, which is a half again, runs sideways. So that's going to be your x coordinate. Square root 3 over 2, or excuse me, a half. And your y coordinate is going to be square root 3 over 2.
Okay.
Up here at 90 plus 30, which is 120 degrees, you're going to go half a unit left. Here's your triangle right here. Short distance left, long distance up. So the short distance is going to be negative a half. Long distance is going to be positive square root 3 over 2. Down here at 270 minus 30, which would be 240, you're going to go short distance left, a long distance down, so they're both going to be negative. Short distance left is going to be negative a half. Long distance down is negative square root 3 over 2. The triangle I'm looking at is right there. All right, last one. It's going to fall right in here. 270 plus 30 is 300 degrees. Short distance right, long distance down. That's going to be 1/2, and then negative square root 3 over 2.